Session Initiation Protocol.
The Session Initiation Protocol is a signaling communications protocol, widely used for controlling multimedia communication sessions such as voice and video calls over Internet Protocol networks. The protocol defines the messages that are sent between endpoints which govern establishment, termination and other essential elements of a call. SIP can be used for creating, modifying and terminating sessions consisting of one or several media streams. SIP can be used for two-party, unicast, or multi-party, multicast, sessions. Other SIP applications include video conferencing, streaming multimedia distribution, instant messaging, presence information, file transfer, fax over IP and online games. Originally designed by Henning Schulzren and Mark Handley in 1996, SIP has been developed and standardized in RFC 3261 under the auspices of the Internet Engineering Task Force, IETF. It is an application layer protocol designed to be independent of the underlying transport layer. It can run on Transmission Control Protocol, TCP, User Datagram Protocol, UDP, or Stream Control Transmission Protocol, SCTP. It is a text-based protocol, incorporating many elements of the Hypertext Transfer Protocol, HTTP, and the Simple Mail Transfer Protocol, SMTP. SIP works in conjunction with several other application layer protocols that identify and carry the session media. Media identification and negotiation is achieved with the Session Description Protocol, SDP. For the transmission of media streams, voice, video, SIP typically employs the Real-Time Transport Protocol, RTP, or Secure Real-Time Transport Protocol, SRTP. For secure transmissions of SIP messages, the protocol may be encrypted with Transport Layer Security, TLS.
History.
SIP was originally designed by Henning Schulzren and Mark Handley in 1996. In November 2000, SIP was accepted as a 3GPP signaling protocol and permanent element of the IP Multimedia Subsystem (IMS) architecture for IP-based streaming multimedia services in cellular systems. The IETF Network Working Group published RFC 3261, as of 2013 the latest version of the specification, in June 2002. The U.S. National Institute of Standards and Technology, NIST, Advanced Networking Technologies Division provides a public domain implementation of the Java standard for SIP which serves as a reference implementation for the standard. The stack can work in proxy server or user agent scenarios and has been used in numerous commercial and research projects. It supports RFC 3261 in full and a number of extension RFCs including RFC 6665, Subscribe/Notify, and RFC 3262, Provisional Reliable Responses, etc.
Protocol design.
SIP employs design elements similar to the HTTP request-response transaction model. Each transaction consists of a client request that invokes a particular method or function on the server and at least one response. SIP reuses most of the header fields, encoding rules and status codes of HTTP, providing a readable text-based format. Each resource of a SIP network, such as a user agent or a voice mailbox, is identified by a Uniform Resource Identifier, URI, based on the general standard syntax also used in web services and email. The URI scheme used for SIP is SIP, and a typical SIP URI is of the form, SIP username password at host, port. If secure transmission is required, the scheme SIPs, is used and mandates that each hop over which the request is forwarded up to the target domain must be secured with Transport Layer Security, TLS. The last hop from the proxy of the target domain to the user agent has to be secured according to local policies. TLS protects against attackers which try to listen on the signaling link, but it does not provide real end-to-end security to prevent espionage and law enforcement interception, as the encryption is only hop by hop and every single intermediate proxy has to be trusted. SIP works in concert with several other protocols and is only involved in the signaling portion of a communication session. SIP clients typically use TCP or UDP on port numbers 5060 and or 5061 to connect to SIP servers and other SIP endpoints. Port 5060 is commonly used for non-encrypted signaling traffic, whereas port 5061 is typically used for traffic encrypted with transport layer security (TLS). SIP is primarily used in setting up and tearing down voice or video calls. It also allows modification of existing calls. The modification can involve changing addresses or ports, inviting more participants, and adding or deleting media streams. SIP has also found applications in messaging applications, such as instant messaging, and event subscription and notification. A suite of SIP-related Internet Engineering Task Force (IETF) rules define behavior for such applications. The voice and video stream communications in SIP applications are carried over another application protocol, the Real-Time Transport Protocol (RTP). Parameters, port numbers, protocols, codecs, for these media streams are defined and negotiated using the Session Description Protocol, SDP, which is transported in the SIP packet body. A motivating goal for SIP was to provide a signaling and call setup protocol for IP-based communications that can support a superset of the call processing functions and features present in the public switched telephone network, PSTN. SIP by itself does not define these features. Rather, its focus is call setup and signaling. The features that permit familiar telephone-like operations, dialing a number, causing a phone to ring, hearing ringback tones or a busy signal, are performed by proxy servers and user agents. Implementation and terminology are different in the SIP world, but to the end user, the behavior is similar. SIP-enabled telephony networks can also implement many of the more advanced call processing features present in Signaling System 7, SS7, though the two protocols themselves are very different. SS7 is a centralized protocol, characterized by a complex central network architecture and dumb endpoints, traditional telephone handsets. SIP is a client-server protocol. However, most SIP-enabled devices may perform both the client and the server role. In general, Session Initiator is a client, and the call recipient performs the server function. SIP features are implemented in the communicating endpoints, contrary to traditional SS7 features, which are implemented in the network. SIP is distinguished by its proponents for having roots in the IP community rather than in the telecommunications industry. SIP has been standardized and governed primarily by the IETF, while other protocols, such as H323, have traditionally been associated with the International Telecommunication Union, ITU. The first proposed standard version, SIP 1.0, was defined by RFC 2543. This version of the protocol was further refined to version 2.0 and clarified in RFC 3261, although some implementations are still relying on the older definitions.
Network elements.
SIP defines user agents as well as several types of server network elements. Two SIP endpoints can communicate without any intervening SIP infrastructure. However, this approach is often impractical for a public service, which needs directory services to locate available nodes on the network.
User agent.
A SIP user agent, UA, is a logical network endpoint used to create or receive SIP messages and thereby manage a SIP session. A SIP UA can perform the role of a user agent client, UAC, which sends SIP requests, and the user agent server, UAS, which receives the requests and returns a SIP response. These roles of UAC and UAS only last for the duration of a SIP transaction. A SIP phone is an IP phone that implements SIP user agent and server functions, which provide the traditional call functions of a telephone, such as dial, answer, reject, hold on hold, and call transfer. SIP phones may be implemented as a hardware device or as a soft phone. As vendors increasingly implement SIP as a standard telephony platform, often driven by 4G efforts, the distinction between hardware-based and software-based SIP phones is being blurred, and SIP elements are implemented in the basic firmware functions of many IP-capable devices. Examples are devices from Nokia and BlackBerry. In SIP, as in HTTP, the user agent may identify itself using a message header field user agent, containing a text description of the software-hardware product involved. The user agent field is sent in request messages, which means that the receiving SIP server can see this information. SIP network elements sometimes store this information, and it can be useful in diagnosing SIP compatibility problems.
Proxy server.
The proxy server is an intermediary entity that acts as both a server and a client for the purpose of making requests on behalf of other clients. A proxy server primarily plays the role of routing, meaning that its job is to ensure that a request is sent to another entity closer to the targeted user. Proxies are also useful for enforcing policy, for example, making sure a user is allowed to make a call. A proxy interprets, and, if necessary, rewrites specific parts of a request message before forwarding it.
Registrar.
A registrar is a SIP endpoint that accepts register requests and places the information it receives in those requests into a location service for the domain it handles. The location service links one or more IP addresses to the SIP URI of the registering agent. The URI uses the SIP scheme, although other protocol schemes are possible, such as telephone. More than one user agent can register at the same URI, with the result that all registered user agents receive the calls to the URI. SIP registrars are logical elements, and are commonly co-located with SIP proxies. But it is also possible and often good for network scalability to place this location service with a redirect server.
Redirect server.
A user agent server that generates 3xx redirection responses to requests it receives, directing the client to contact an alternate set of URIs. The redirect server allows proxy servers to direct SIP session invitations to external domains.
Session border controller.
Session border controllers serve as middle boxes between UA and SIP servers for various types of functions, including network topology hiding, and assistance in NAT traversal.
Gateway.
Gateways can be used to interface a SIP network to other networks, such as the public switched telephone network, which use different protocols or technologies.
SIP messages.
SIP is a text-based protocol with syntax similar to that of HTTP. There are two different types of SIP messages, requests and responses. The first line of a request has a method, defining the nature of the request, and a request URI, indicating where the request should be sent. The first line of a response has a response code. For SIP requests, RFC 3261 defines the following methods. Register, used by a UA to indicate its current IP address and the URLs for which it would like to receive calls. Invite, used to establish a media session between user agents. ACK, confirms reliable message exchanges. Cancel, terminates a pending request. Bye, terminates a session between two users in a conference. Options, requests information about the capabilities of a caller, without setting up a call. A new method has been introduced in SIP in RFC 3262. PRACK, Provisional Response Acknowledgement. PRACK improves network reliability by adding an acknowledgement system to the provisional responses, 1xx. PRACK is sent in response to provisional response, 1xx. The SIP response types defined in RFC 3261 fall in one of the following categories. Provisional, 1xx, request received and being processed, success, 2xx, the action was successfully received, understood, and accepted, redirection, 3xx, further action needs to be taken, typically by sender, To complete the request, client error, 4xx, the request contains bad syntax or cannot be fulfilled at the server. Server error, 5xx, the server failed to fulfill an apparently valid request. Global failure, 6xx, the request cannot be fulfilled at any server.
Transactions.
SIP makes use of transactions to control the exchanges between participants and deliver messages reliably. The transactions maintain an internal state and make use of timers. Client transactions send requests and server transactions respond to those requests with one or more responses. The responses may include 0 or more provisional, 1xx, responses and 1 or more final, 2xxxxx, responses. Transactions are further categorized as either invite or non-invite. Invite transactions differ in that they can establish a long-running conversation, referred to as a dialogue in SIP, and so include an acknowledgement, ACK, of any non-failing final response, for example 200 OK. Because of these transactional mechanisms, SIP can make use of unreliable transport such as User Datagram Protocol, UDP. If we take the above example, User 1's UAC uses an invite client transaction to send the initial invite, 1, message. If no response is received after a timer-controlled wait period, the UAC may have chosen to terminate the transaction or retransmit the invite. However, once a response was received, User 1 was confident the invite was delivered reliably. User 1's UAC then must acknowledge the response. On delivery of the ACK, too, both sides of the transaction are complete. And in this case, a dialogue may have been established.
Instant messaging and presence.
The Session Initiation Protocol for Instant Messaging and Presence Leveraging Extensions, SIMPLE, is the SIP-based suite of standards for instant messaging and presence information. MSRP, Message Session Relay Protocol, allows instant message sessions and file transfer.
Conformance testing.
TTCN3 test specification language is used for the purposes of specifying conformance tests for SIP implementations. SIP Test Suite is developed by a specialist task force at ETSI, STF 196. The SIP developer community meets regularly at the SIP Forum SIPIT events to test interoperability and test implementations of newer FCs.
Applications.
The market for consumer SIP devices continues to expand. There are many devices such as SIP terminal adapters, SIP gateways, and SIP trunking services providing replacements for ISDN telephone lines. Many VoIP phone companies allow customers to use their own SIP devices, such as SIP-capable telephone sets, or softphones. SIP-enabled video surveillance cameras can make calls to alert the owner or operator that an event has occurred. For example, to notify that motion has been detected out of hours in a protected area. SIP is used in audio over IP for broadcasting applications where it provides an interoperable means for audio interfaces from different manufacturers to make connections with one another.
SIP-ISUP interworking.
SIP-I, or the Session Initiation Protocol with Encapsulated ISUP, is a protocol used to create, modify, and terminate communication sessions based on ISUP using SIP and IP networks. Services using SIP-I include voice, video telephony, fax and data. SIP-I and SIP-T are two protocols with similar features, notably to allow ISUP messages to be transported over SIP networks. This preserves all of the detail available in the ISUP header, which is important as there are many country-specific variants of ISUP that have been implemented over the last 30 years, and it is not always possible to express all of the same detail using a native SIP message. SIP-I was defined by the ITUT, where SIP-T was defined via the IETF-RFC route. A Session Initiation Protocol, SIP, connection is a voice over Internet Protocol, VoIP, service offered by many Internet telephony service providers, ITSPs, that connects a company's private branch exchange, PBX, telephone system to the public switched telephone network, PSTN, via the Internet. Using a SIP connection may simplify administration for the organization, as the SIP connection typically uses the same Internet access that is used for data. This often removes the need to install Basic Rate Interface, BRI, or Primary Rate Interface, PRI, telephone circuits.
Deployment issues.
If the call traffic runs on the same connection with other traffic, such as email or web browsing, voice and even signaling packets may be dropped and the voice stream may be interrupted. To mitigate this, many companies split voice and data between two separate Internet connections. Alternately, some networks use the TOS precedence or diffserv fields in the header of IPv4 packets to mark the relative time sensitivity of SIP and RTP as compared to web, email, video and other types of IP traffic. This precedence marking method requires that all routers in the SIP and RTP paths support separate queues for different traffic types. Other options to control delay and loss include incorporating multiple VLANs, virtual local area networks, traffic shaping to avoid this resource conflict, but the efficacy of this solution is dependent on the number of packets dropped between the Internet and the PBX. Registration is required if the end user has a dynamic IP address, if the provider does not support static host names, or if NAT is used. In order to share several DID numbers on the same registration, the IETF has defined additional headers, for example P-preferred identity, CRFC 3325. This avoids multiple registrations from one PBX to the same provider. Using this method, the PBX can indicate what identity should be presented to the called party and what identity should be used for authenticating the call. This feature is also useful when the PBX redirects an incoming call to a PSTN number, for example a cell phone, to preserve the original caller ID. Users should also be aware that a SIP connection can be used as a channel for attacking the company's internal networks, similar to web and email attacks. Users should consider installing appropriate security mechanisms to prevent malicious attacks.
Encryption.
The increasing concerns about security of calls that run over the public Internet has made SIP encryption more popular. Because VPN is not an option for most service providers that offer secure SIP, SIPS, connections use TLS for securing signaling. The relationship between SIP, port 5060, and SIPS, port 5061, is similar to that as for HTTP and HTTPS, and uses URIs in the form SIPs, user@example.com. The media streams, which occur on different connections to the signaling stream, can be encrypted with SATP. The key exchange for SATP is performed with SDES, RFC 4568. Or the newer and often more user-friendly ZRTP, RFC 6189, which can automatically upgrade RTP to SATP using dynamic key exchange, and a verification phrase. One can also add a MI key, RFC 3830, exchange to SIP and in that way determine session keys for use with SATP. The Simple Mail Transfer Protocol, SMTP. SIP works in conjunction with several other application layer protocols that identify and carry the session media. Media identification and negotiation is achieved with the Session Description Protocol, SDP. For the transmission of media streams, voice, video, SIP typically employs the Real-Time Transport Protocol, RTP, or Secure Real-Time Transport Protocol, SRTP. E3261 under the auspices of the Internet Engineering Task Force, IETF. It is an application layer protocol designed to be independent of the underlying transport layer. It can run on Transmission Control Protocol, TCP, User Datagram Protocol, UDP, or Stream Controlled Transmission Protocol, SCTP. It is a text-based protocol, incorporating many elements of the Hypertext Transfer Protocol, HTTP, and
Session Initiation Protocol.
The Session Initiation Protocol is a signaling communications protocol, widely used for controlling multimedia communication sessions such as voice and video calls over Internet Protocol networks. The protocol defines the messages that are sent between endpoints which govern establishment, termination and other essential elements of a call. SIP can be used for creating, modifying and terminating sessions consisting of one or several media streams. SIP can be used for two-party, unicast, or multi-party, multicast, sessions. Other SIP applications include video conferencing, streaming multimedia distribution, instant messaging, presence information, file transfer, fax over IP and online games. Originally designed by Henning Scholzren and Mark Handley in 1996, SIP has been developed and standardized in RFC. For secure transmissions of SIP messages, the protocol may be encrypted with Transport Layer Security (TLS).
History.
SIP was originally designed by Henning Scholzren and Mark Handley in 1996. In November 2000, SIP was accepted as a 3GPP signaling protocol and permanent element of the IP Multimedia Subsystem (IMS) architecture for IP-based streaming multimedia services.